Hey everybody, Dr. A here, and in this video we're going to be exploring another example of analyzing force vectors using vector components. And specifically, we're going to be exploring this example using a vector parallelogram. So let's go ahead and look at the given information. We're being told to resolve the vector into components along the u and v axes using a force parallelogram and triangle. So let's take a look at what we're given here. We see that we have our regular Cartesian y and x axes, and we're given this vector coming out of the origin of 180 newtons at a 30-degree angle from the positive x-axis. Now, the two axes that we're interested in finding the components of this vector along are the v-axis here, which is at a 15-degree angle away from the positive y-axis, and the u-axis down here, which is at a 40-degree angle below the positive x-axis. So ultimately what we want to do is we want to take this vector, 180 newtons, and decompose it into a component along this v-axis and another component along this u-axis. And we want to do that using a vector or force parallelogram and accompanying triangle, okay? So let's go ahead and get started. I'm going to start with writing solution here. And I'm going to make a note here. I'm going to say let's begin by drawing the force, or sometimes we call it vector parallelogram. Okay, so what we do is we're going to go ahead and redraw this. Now, just to redraw it as identical as possible, I'm going to copy this drawing that I drew already and paste it here. Okay, and what we're going to do is project parallel lines that are parallel to the u-axis and to the v-axis by taking this 180 Newton force as like a resultant. So it's kind of like we think of this 180 Newton force as the resultant of two other force vectors that we're trying to find. So it's almost like going in the opposite direction from what we did in our previous video, okay, our previous example. So here's what I'm going to do. I'm going to use this green color here, and I'm going to draw this line here, this green line. And this line in green is parallel to this v-axis. And similarly, I'm going to draw another line here. And this second green line is parallel to the u-axis. So what I've done is I've formed a parallelogram right here, okay? And so what I'm ultimately looking for is this force right here, which I can call F sub u, and this force lying along the v-axis, which I'm going to call that F sub v. Okay, so there's my parallelogram. Now, what I'm also going to need to note here is some relevant angles. Okay, so what are some important angles that we need to note here? Well, first, we're going to need to observe what is the angle in between the v-axis and my original vector of 180 newtons. Well, we can pretty easily get that as 45 degrees. Okay, so I can get this little angle right here as 45 degrees. How do I know that? Well, I take the 90-degree angle here, and I say 90 degrees minus 15 and also minus 30. Okay, and so if I do 90 minus 15 minus 30, that leaves me with 45 degrees in between this v-axis and my given vector, okay? And then the other angle we need is the angle in between the vector and the u-axis. Well, that one we can pretty obviously see is 70 degrees because we can see that that's 30 plus 40 degrees, okay? So that'll be a 70-degree interior angle there. The next thing I'm going to do is peel out one of these triangles. So remember, these two triangles that form this parallelogram are pretty much equivalent to each other. They're the same triangle, they're just kind of symmetrical with respect to this 180 Newton force. So I can look at either one of them. Let's go ahead and peel out this top triangle. And when we do that, we're going to form this top triangle by translating FU up to this green line right here, okay? And so if I redraw this as a forced triangle, how about I draw it over here? If I redraw this as a forced triangle, I've got F sub V here, okay? And then I'm gonna draw this F sub U right here. Okay, and all I did was I translated this orange F sub U and superimposed it on top of this green line here to create this, this double vector shape. And then I still have my 180 Newton vector hanging out there, okay? And so what are these angles here that I have? Well, we already know that this one is 45 degrees, okay? So let me draw that a little bit better, 45 degrees. And then what about this angle over here? Well, this is that 70-degree angle, okay? How do I know that? Well, again, we know that this is 70 down here, and these two lines are parallel, and so this angle up here is an alternate interior angle that's also 70 degrees. And so that's going to leave us with an interior angle over here of 65 degrees, okay? So be very careful, even though the way I drew this kind of free-handed, this might look like it's 90 degrees, but it's not. It's actually 65 degrees. So if I were to draw this a little bit more to scale and more nice and neatly, that should show as an acute 65-degree angle, okay? So now what I'm going to do is I'm going to apply law of sines to the force triangle, okay? And so when I do that, I'm going to say that the magnitude of F sub V divided by the sine of 70 degrees is equal to the magnitude of F sub U divided by the sine of 45 degrees equals 180 newtons over the sine of 65 degrees. So if you remember law of sines, we say the sine of an interior angle divided by its opposite length, side length, is equal to the side of the other interior angle divided by its opposite side length, also equals the sine of the other interior angle divided by its opposite side length. And we can use those relationships as reciprocals of each other as well. And so what I'm basically going to do here is I'm going to say F sub V magnitude over sine of 70 degrees equals 180 newtons over sine of 65 degrees. So I've set this term equal to this third term, and I can do some rearranging, and I'll get F sub V magnitude is equal to 186.6 newtons. And then similarly, I'm going to say the magnitude of F sub U over sine of 45 degrees is equal to 180 newtons over sine of 65 degrees. Do a little bit of rearranging, and I'll get the magnitude of F sub U is equal to 140.3 newtons. And these are my final answers. Now, again, I could round these maybe to 3 sig figs and still be okay with that. But regardless, this is how we do it, and this is what we get for those two force components along those two axes, V and U. So if you found this helpful, please hit like and subscribe, and be on the lookout for other content like this. Thanks for watching.